The coastal community of Waterford, Connecticut is named for the relative abundance of just what the name implies, water. We are surrounded by lakes, ponds, streams, and our most distinctive feature, our proximity to Long Island Sound. The Sound is an estuary environment, a place where the rivers of the mainland meet the sea. Estuaries all over the world, places like Chesapeake Bay and the Gulf of Mexico, are unique aquatic environments in that they support a wide variety of important birds and mammals, significant both in ecological and economical value. 8 million people live on and around the Sound and use its resources for recreation, commercial fishing, and boating, activities which contribute $5 billion to our economy each year. The Sound provides habitat and protection for thousands of species of fish, birds, and mammals that thrive in its nutrient-filled salt marshes and sandy beaches. In short, our Long Island Sound is a vital part of the culture, economy, and ecology of our region and beyond. But Long Island Sound is in danger. Threats from untreated sewage, chemical runoff, marine waste, and countless other hazards jeopardize the fragile balance of the estuary environment. Developers are inching further and further towards the shore, destroying salt marshes that have protected our shores and provided a nursery environment for marine creatures for centuries. Power plants along the shore that use the Sound's water for cooling kill millions of larvae as they pass through the intake and cooling chambers, which could cause a drop in the population of organisms that support the fishing and harvesting industries of Connecticut and beyond. The collateral damage of human development on the shores could spell disaster for the very estuary that first drew us to inhabit the coasts of Long Island Sound. Hi, my name is Phil Potter. I'm a senior at Waterford High School and have, for the past year, been enrolled in Mr. Michael O'Connor's Advanced Oceanology course. One aspect of this course was to pursue a year-long research project that addressed a local issue, one that involved aspects of community service in its requirements. I chose the ever-present issue of non-point source pollution in Long Island Sound. Being a resident of Waterford, and in a broader sense, a resident of the Long Island Sound watershed, I was aware of the issues concerning the health of the Sound and concerned about the effects of this pollution. This presentation is meant to give a glimpse of one aspect of the Sound's pollution crisis and the efforts right here in Waterford to help plan for a more environmentally aware future. Why should you care about this problem? Because of the many issues facing Long Island Sound today, non-point source pollution is one that you can take an active part in correcting, just by being more aware in your everyday actions. But we'll save the solutions for later. First, what exactly is non-point source pollution? As defined by the Department of Natural Resources, non-point source pollution is water pollution that is generated by land use activities, rather than from an identifiable facility. It is conveyed to waterways through natural processes, such as rainfall, storm runoff, or groundwater seepage, rather than by deliberate discharge. While point source pollution can generally be traced to a specific discharge site, non-point source pollution occurs over a wide area and is not easily identified. While discharge from sewer and solid waste plants are treated with chemicals before entering the Sound, non-point source pollutants flow directly into the waters. Included in the runoff are sediments, nutrients from fertilizers and sewage treatment plants, animal waste, pesticides, excess salts, and toxins from manufactured and refined products like oils, paints, and antifreeze. These contaminants, when introduced to the Sound in excess, take their toll on the health of the estuary. As an example, nitrogen is responsible for the low dissolved oxygen content, or hypoxia, in Long Island Sound today, a condition that is responsible for widespread fish kills, especially in the summer months. Non-point source pollution is believed to be responsible for more than 21% of this nitrogen entering the Sound. It is also the third largest major source of toxins and pathogens in the Sound, following tributaries and sewage treatment plants. These excess pathogens have played a major part in the classification of 35% of Connecticut's shellfish beds as restricted or prohibited. Non-point source pollution is a chief contributor to pollutants that impair the health of Long Island Sound. So how does non-point source pollution get from my neighborhood to Long Island Sound? That's a good question. The main method of transportation for these pollutants in southeastern Connecticut is our stormwater sewage system. What many people in our area don't realize is that no matter how far you are from the Sound, be it 10 feet or 10 miles, everything you dump in your drains ends up in Long Island Sound. To prove this point, here's an example of one stormwater drain and the path that its contents take to eventually reach the Sound. We start our journey on a typical Waterford street. This is Brayman Road in the Great Neck area of town. Runoff, including oils, pesticides, antifreeze, and solid waste, gets into the water stream from passing cars and human activity. These pollutants travel down into sewer drains, through concrete pipes, and into an open stream where they are carried towards the Sound. The stream passes behind Goundry Drive and collects in a pond near the end of the street, where residents use the water for fishing in the summer and skating in the winter. From there it continues through the woods, southward, until it passes underneath a dirt road. Eventually, the stream crosses under Great Neck Road near the entrance to Harkness State Park. From there it enters the protected salt marshes to the western side of Harkness. From these salt marshes, eventually, this stream and all others in Waterford make their way into the Sound. With them comes the man-made pollutants that poison our beloved estuary. In developing the shores of the Sound, we have put a wrench in Mother Nature's works. Before human intervention, rainwater was completely absorbed by the forest floor and filtered through the soil before reaching the major waterways. In today's world, many forest surfaces have been paved over by impervious surfaces, or ones that do not allow water to penetrate. Instead of filtering through the ground using natural processes, the rainwater is conveyed directly from the roads to the equally impervious stormwater sewage systems, and directly into Long Island Sound, along with any pollutants it picks up along the way. As more and more of New England is covered with impervious surfaces, the problem gets larger and larger. So you may be asking yourself, why should I care about all of this? That's a great question. The reason Waterford residents should be interested in this issue is that there is an ongoing study in our very own town that could have major implications for the treatment of non-point source pollution in the future. Many people pass by Giovanni Drive in Waterford on a regular basis, regarding the development as just another cul-de-sac off of Fog Plain Road. But, as I was privileged to investigate, there is much more to this neighborhood than meets the eye. Giovanni Drive is an experimental development managed by the University of Connecticut's Department of Natural Resources Management and Engineering. It is funded by a grant from the U.S. Environmental Protection Agency. Basically, the project is designed to test out ways to reduce non-point source pollution from leaving a residential development and reaching major waterways. To learn more about the development, I met and explored the site with UConn's Mark Hood. I'm here today with Mark Hood from UConn Natural Resources Department here on Giovanni Drive. Mark, can you tell us what you do in the project?
Well, my job on the project is sort of like a day-to-day manager of the project. As a graduate student, I do the maintenance of the equipment, the sample gathering equipment. I gather the samples, I transport them back to the laboratory, where I also help in the analysis of the samples.
Giovanni Drive is split up into two sections, the traditional development and the experimental development. Here, Mark shows me the monitoring site for the traditional section.
This is one of our three monitoring sites. We have three different monitoring sites. One in our low impact development section, one here in the traditionally built section, and the third one over in the control section. So these are sites we check on a weekly basis. And let me just show you what we got here. This one is a traditionally developed neighborhood with, I believe it's a 24-foot wide road and a stormwater sewage system, which is the grates and the piping.
Right.
And that's what we're actually sampling here. I believe there's 9 sewer grates that collects the water from this, I think it's a 5 hectare, or I'm not sure about the size of the area, but they collect the stormwater that falls on these, I think 19 houses, and it runs down this section of Giovanni Drive, and it comes out through this pipe. And what we have here is a 15-inch Palmer Bowell flume, and using the flume, we can determine the height of the water. There's actually a pressure bubble gauge down at the bottom of the flume, and as the water level rises in the pipe, we can determine what the volume of water that's exported from the site is, which is actually a pretty significant measurement, because what we're finding is that the actual volume of water exported is significantly reduced using the low impact development measurements. That's exactly what low impact development is all about. If you can keep the water on site instead of leaving the site, and a lot of people don't realize that when water goes into a stormwater sewer, it doesn't go to a treatment plant, it goes straight into a river,
straight into the sound.
and then that goes straight into the sound.
Right.
So it all ends up going, if it goes in the ground, it pretty much goes in the sound.
Right.
But even so, there was less runoff exported from this site before these houses were put here. Once they put the houses in, you start exporting a whole lot more water. It's the impervious surfaces, it's the roofs, it's the driveways, it's the roads itself, it's the sidewalks. They all contribute to increased runoff, which is what we're trying to reduce.
Right. And even though we're in relative terms, far away from the sound, the water still makes its way straight to there through a lot of different channels, right?
Sure, yeah, the Connecticut River drainage basin, which all drains to the sound, comes as far from Canada.
Right.
So it's a huge area, and whether it makes it into a river, you're still going to end up with increased volume, which ends up eroding your river and creating more non-point source pollution. Or it could go to a pond or a lake. And in a pond or a lake, you'll often get eutrophication, which is the over-enrichment of nutrients in a pond or a lake that ends up causing excessive growths of algae.
Yeah, algal blooms, right?
And those lead to fish kills often. When the algae dies, that consumes all the oxygen in the pond, and that'll lead to a fish kill. The same thing happens in Long Island Sound.
Mark and I then moved up into the experimental section of the development, and he showed me some of the BMPs, or best management practices, in use on this site.
Well, here we are in the low impact development section of our study, and what we're standing in right here is a pretty significant part of the low impact development measures. This is a grass swale. So in the regular development neighborhood, you have a stormwater sewage system, which basically pipes the stormwater away from a site as fast as possible. Here in the swale, the grass slows the rainwater, makes it go a little bit slower, and it also allows it to infiltrate into the groundwater, which again is what low impact development is all about. It's keeping the water on site. And also we have a bioretention area, otherwise known as a rain garden, right here. And that catches runoff from these downspouts. So instead of going onto the road, getting transported away, the water's allowed to pond in this tiny little depression up to about 6 inches. And then over the next day or so, the water is allowed to infiltrate into the ground. Again, holding the water on site, kind of mimicking, this rain garden almost mimics a forest environment that was here before development, which has a lot of infiltration. The paved surfaces and the roofs and even the lawn itself doesn't have a lot of infiltration, but the rain garden helps infiltrate the water into the ground because it has that healthy ecosystem